Okay, Trig Kids, this is the second half of section 8.1, where we are graphing trig functions using a graphing calculator, trying to find the solution based upon that. So in example 4, so we only have 2 examples left. Example 4, they don't tell us which method to use, the x-intercept method or the intersection method. So I'm going to go ahead and do this one using the x-intercept method. Okay, which means that we need to take these 2 functions and we need to put them on the same side. I guess that's probably what they've done here, because there's not 2 functions that are intersecting each other. So I'm going to move this sign to the other side, and it doesn't really matter which one you move. So I'm going to leave the tangent on this side. This would be minus 3 sine of 2x equals 0. And then I'm going to plug that into my calculator just for my y1. Okay. Still want to be in radians. That's what this graph is showing over here. So I want to make sure that I am still in radians. Let me go to mode. Yep, radians still there. And y equals. I'm going to clear him out, and I'm going to start over with tangent x minus 3 sine of 2x. Okay, I'm going to go to my window and see what my window is at. My window is going from 0 to 2 pi. Okay, they're showing over here negative pi over 2 to positive pi over 2. I'm going to go, let's go negative pi instead to positive pi. Okay, and then my y's, they went negative 3 to 3. Sure, we'll go with negative 3 to 3. Again, this is just kind of guessing. I'm cheating by going off of what they have. But, you just kind of guess and narrow it down after you graph the first time. You can kind of see where your limits might need to be, or where your new stuff needs to be. So we did ours a little bit wider than what they have here. So they're just showing this chunk. And so we have 3 places before he starts to repeat again that we need to pinpoint and limit down and find those guys. Okay, so I'm going to go zoom in. I'm not going to do this the table way. I'm going to go ahead and just find where they're located at. So my little crosshairs here, I'm going to zoom in. I'm going to hit enter. I'm going to see where he touches at. Come on. This graph kind of takes a while. Okay, if I wanted to zoom in a little bit further, I sure could, but I'm going to say right about negative 1.15 is going to be the first place he's going to touch. Negative 1.15. Okay, then we're going to, I'm going to zoom out. Oh, and it's going to take forever graphing again. Come on. Okay, so my first one that I plotted was this negative 1.15 here. Right here is the next place he's going to cross, and I'm guessing that's going to be right at 0. So I'm going to go ahead and put x equals 0, just because I'm going to cheat. I'm guessing this one over here is going to be a positive 1.15, but let's zoom over, or let's go over and let's zoom in on him and see if that's exactly where he's at. Okay, because he kind of looks like he's symmetric. Brad. Child is not happy. Zoom in. There we go. Okay, so I'm zooming in on that spot right there. Enter. Let's see if he is a positive 1.15. Is what I'm guessing he's going to be at. She did have an app today even. I don't know what her deal is. Yes, positive 1.15. Okay, so I've got those 3 places. And then he's going to, repeat that process again. He's going to go over here and he's going to do that kind of same, it almost looks like a tangent function, but he kind of does that little wave in the middle, and that's where the sine comes into play. So tangent kind of should look like a cubic function. He's going up, and he has vertical asymptotes on either side. But the sine is going to what makes him do like a little wave in the middle. Okay, so we need to do plus something plus something plus something. How far later before he's going to repeat himself again, okay? And so here's where we have like conflicting things going on, okay? The period of tangent normally is pi, right? And the period of sine is normally 2 pi. So it's like, well, which one do we use? We use pi or 2 pi? Well, here's the deal. Sine actually has a 2 in front of here, 2 in front of that x. And if you remember, when we're doing the period of like sine of 2x, that 2, what I need to do is I need to take 2 pi and divide by b. Like 2 pi over b is the formula. 2 pi divided by 2, that 2 in there will make it so that this guy is just pi. So really, since that 2 is there, it takes my period from being 2 pi to actually just pi, and then both of them are consistent with that. Both of them agree that it should be pi times n, and pi times n, and pi times n. That's what I'm adding each time. So pi n later, he's going to be touching at each one of those points. Okay. Example 5 is exactly the same thing. We're going to do the x-intercept method. Except this time they want it in degree measure. So I'm going to go and we're going to see how this changes. I'm going to go from radians over to degrees. So change yours also. Second quit. Okay. Y equals, I'm going to clear him out and I'm going to type this function in here. So I have 2 parentheses sine of x, close parentheses, and then square. That's the equivalent of, that's how you're going to write. I need another parentheses in there maybe. That's how you're going to write that function squared, okay? Minus 3 sine of x. We don't have a theta symbol, so we just use x. And then minus 3, and then I'm going to graph him, okay? But before I graph him, my window, if I leave my window as this is going to go from like 0.4 degrees to 1.9 degrees, okay, not radians any longer. It's going to all be in degrees, okay? So what I'm going to do instead is, like before we would go from 0 to 2 pi, well, the equivalent of 2 pi is 360, okay? So let's go 0 to 360, because now we're in degrees, so we need to make our ranges a little bit different. And then they go -5 to +3. Okay, -5, +3, hit graph, and we're going to get the same thing as what they have over here, okay? Now, we could have started with -1 to 1, but you would only see like this little chunk in here, so we would know then that we would kind of need to widen him out a little bit, okay? If we wanted to go, let me show you window. Let's go from like -360 to 720 here instead, and let's see what his graph looks like. Oops, 720. Okay, and I'll show you. If I go -360 to 720, that's going to have 3 of these little chunks in there, and you can kind of see how that works out. So there's the first chunk, there's the next chunk, and then I have a third chunk there, okay? So they are just doing this section from here to here by putting it on this graph, okay? So then I just need to determine how many places he's going to, or how many solutions I'm going to have for my theta. They call it theta in this case. I'm going to have 2 places where he touches, or 2 x-intercepts, so I'll have 2 solutions for theta. So I just need to pinpoint those 2, and then I need to solve, or put like plus whatever n and plus whatever n, okay? To note that he's gonna hit those places that far later, okay? So this first guy, I'm going to zoom in, and we're kind of cheating by just guessing, or we're not really cheating. We're being lazy, I guess, by just you know, not going into our table and going out to however many decimal places. But I'm going to say that this is good enough. Okay. So that first place where he's touching, okay, I have y is at 5e to the -10th power, which is a number that's really, really, really close to 0. So he's basically on 0 on the y-axis, and he is at 223.1 degrees about. Okay, so 223.1 degrees, and then I'm going to go over to this guy. Okay, we can zoom in further if we want to get that more exact. but he's going to touch right there about 315. So 315 is going to touch again, and those are going to be my 2 places. Okay, first one is here, second one is here, and then how much later? Well, if we think about sine, that's the only trig function that I have going on here. Sine's period is 2 pi. But since we are in degrees, we need to convert that to degrees. Rather than being 2 pi, we're going to use 360. So every 360 n later, he's going to touch at those 2 places again, okay? And now I haven't really talked about the n at all, but that n means that, like, if I plug in 1 for n, that would be 223.1 plus 360. If I plug in 2 for n, that would be 223.1 plus 720. If I plug in 3 for n, that would be another 360 after that, okay? I could also plug negative numbers in for n, being like -1. And that would be this guy going back the other direction. So that would be subtracting 360, okay? Some of you guys have talked about before where you like to do plus or minus instead of that. So you really don't have to do the plus and minus. If you want to, you sure can write your answer that way. But by saying n here, n can be an integer, which means he can be negative numbers also, which would be the equivalent of subtracting that 360, okay? So a lot of you guys I know like to put plus and minus that whatever n. You know, if you just had plus, it's an okay answer because n could then be negative, okay? So just however you prefer to write it, but this is what he would look like in degree measure, okay? So just keep in mind that this number is based upon what the period is. If you have 2 trig functions, they have to kind of agree upon what the period will be, and that's why they have that 2 here in front of the sign, is because that will change sine's period from 2 pi to just pi, okay? All right, that's what I have for section 8.1.